All right, good morning. I'm back after quite some time. I took a small break. I feel rested now. Now, this question is from the concept of free fall. Okay, so free fall is very important, and the reason I've chosen this question is because I find a lot of students getting confused on the concept when, especially, this question is in front of them. So today I will solve the mystery and give you some tricks how to solve these questions. Let's read the question first. So as you can see, there is a hot air balloon which is ascending up. Okay, so you can see the diagram. And then there is a package which is dropped 80 meters above the ground. Okay, so let's see the situation and understand what's happening there. So this is the package, and when the package is dropped, this is at 80 meters, by the way. Okay, and 80 meters is this distance, 80 meters. All right, so the package is dropped, and at that point the balloon is ascending with a velocity of 12 meter per second. This is the speed at which the balloon is ascending. The question is, how long does this package take to reach the ground? So if I were to show you the complete diagram, this is your ground. Okay, and the package obviously will come down due to free fall, the acceleration due to gravity. The second question is, with what speed does this package hit the ground? All right. Now, I hope the situation is clear to you, the figure is clear to you, but I'll tell you where is the confusion. Most of the students solve this in a particular manner, but I will give you some more concepts so that you can solve these questions easily and much faster than what you've been doing. All right, so let's start solving this uh, in a faster manner. All right, so let's spend some seconds on understanding what is the situation. See, once this box, the package detached from the balloon, it's the actual trajectory is not that it is going to start falling downwards like this. Okay, the actual trajectory is the moment this disconnects from the balloon. So look at the now, look at this instant when it detaches from the balloon. This is a whole trajectory. If I were to draw the trajectory, the package, when it detaches, it goes up and then it goes down. Okay, so this is the way it works out. And so let me just redo this. So let's concentrate on the package here. So the package got detached. Okay, and the balloon goes its own way. Okay, see, the balloon is, and the package, okay, let's not focus on the balloon now because the balloon is no longer part of the system. The package goes up. After a certain while it hits the highest point, then it starts coming down and hits the ground. This is the way this has to be looked at, right? So it is hitting the ground now, and we have to find the velocity at this point of time. All right, so you can see this is the point of detachment. Okay, and this is where the balloon and the package detached. The distance is 80 meters. We've already seen this. The balloon continues its upward journey, so it's no longer visible. You can see, I told you the package goes up for a certain time, but here the acceleration is making it slow down because the direction of gravity is downward here. It reaches the highest point. So maybe this was the highest point. So let's say this is the highest point it touches. Here its velocity, final velocity, becomes zero. And then it starts coming down, towards the ground. So now this is coming towards the ground, I'm showing you. And then finally, in the last stage, you can see it is hitting the ground, right? So this is the ground level where it hits. We have to find the velocity at this point. And all the while when it is coming down, the acceleration is plus g. Why I'm writing plus, I will tell you, is conventionally we treat this as plus, but we will get into details of this. The speed is increasing, right? The velocity will increase, and this will fall with a thud on the ground with great velocity, right? And then so I hope the motion is clear. A lot of students, when they solve this problem. Okay, all right. This is the way they visualize the question, and that really complicates the matter. And even I, as a student, would do this initially. But I'll tell you a trick. Instead of dividing the motion into two parts, first concentrating on the first part, which is from the point of detachment, from where package detaches, it goes up. So you can analyze this part, and obviously the acceleration is uniform. So this is uniform acceleration. So you can use all those three equations of motion, and then you split the motion into second part, which is the downward journey. So you could split the motion into the second part and do the whole calculation based on this motion number A and then motion number B. Right? This is your motion number A, upward and downward. So upward, it is decelerating because the velocity is slowing, the velocity is reducing, and when it comes down, it is accelerating, right? And I have written it. So I hope this. So generally, when students learn this topic, this is the way they solve this, and there is nothing wrong in solving it like this. Okay, it just is a good way to learn physics is by doing what you're doing. Do motion number A, and then do the motion number B. Go to the highest point, then start falling down, reach the ground. Nothing wrong, absolutely. But today I'm here to tell you something interesting, and that is more to do with deeper level of physics, which is understanding the sign convention and using sign convention to your advantage. Can you use sign convention to your advantage? Because the problem is in the examination you have very little time, and therefore you would like to optimize on the time. You don't want to waste your time, and therefore you should have a smarter way to solve this problem. And that is what my aim here is today. I'm going to tell you a smarter way, but before I do that, let me give you 2 cents on the concept of signage, which is the sign convention that we use. Okay, so I'm going to use a graph and then explain you how I'm going to use this sign. So we are now concentrating on sign convention. So if this is your ground, okay, this is your ground. You could choose anything as a ground. Even the point of detachment could be your ground. Anything which is, so let me draw the x's, okay, because we're dealing in vertical motion, fall. This is y and this is y dash. Anything which is going upwards, all right, if it is going up, has a positive sign. Anything which is downward, okay, because it is towards negative side of things, has a negative sign. So instead of focusing on, like I told you, here I just casually wrote plus g. Okay, I wrote plus g because I felt it's accelerating. Just write it plus. I will. So before we dwell deep inside sign convention, let's be very clear that we understand what is acceleration and deceleration. A lot of students struggle with this concept also, and therefore I made sure that I make you understand the physical world, how the physical world views as acceleration and deceleration. That is a beginner or a conventional person or layman visualizes acceleration is not the way physics visualizes acceleration. These are two different things altogether. If you find that a body is coming down very fast, right, very fast downwards, you immediately say that this is acceleration. Nothing wrong in that, right? This is acceleration. If you find a body is slowing down, for example, it is going up and it is slowing down, you say it is deceleration, right? Nothing wrong again, right? I am absolutely in for this, but physics has a typical way of defining acceleration and deceleration, which is what you need to think about, because combined with sign convention, this concept of acceleration and deceleration, which I'm going to explain, has to be used. Understand what is acceleration and deceleration, and then sign convention. If a body is going up, but the acceleration is going in the opposite direction, okay? So there is a mismatch between acceleration and velocity. We will say the body is decelerating, okay? Decelerating, okay? If the acceleration and velocity direction are opposite of each other. This holds true for the horizontal motion also, right? Your car is going in a certain direction like this, right? But you're applying brakes, which means your acceleration is opposite, right? Is here because you're applying brakes. So this is your acceleration, but your car is going forward. What we will say, this is case of deceleration. So whenever the direction of velocity and acceleration are opposite, this is going to be deceleration. However, if you accelerate, your velocity is in the same direction as acceleration. Whenever you see the velocity and acceleration in the same direction, right? So this is your acceleration, all right? They have to be in the same direction. So this is one thing you must know when you're solving these types of problems. You will encounter this many a times in, right? So word on the concept of the sign convention. So sign convention says that if you have a situation like this where the first thing you have to do in a sign convention is identify the origin. All the physical quantities which are upward, okay, upward, will be treated as positive. All the physical quantities which are downward with respect to origin will be treated as negative. So for example, if you throw a ball, which is with some force uh, upwards, okay, you throw this ball with a force, okay, and you throw this ball with the force, you have a situation where the acceleration due to gravity is downward, so acceleration will be treated as negative, and then your upward velocity will be treated as positive. So the sign convention only is worried about upward and downward direction. The good part and the smart part of sign convention is it relieves you of the burden of worrying about the interim motion. The sign convention only worries about the initial and final point. The initial and final point is the worry of sign convention. It does not burden you extra with going up, and then you are coming down, and you have to analyze the motion separately for these two. You don't have to worry about this. You just need to worry about the starting point and the final point. So if you throw the body from, for example, on the ground, and you come back to the ground, your net displacement is zero. If you throw the body upwards, it goes up, and then it goes down, your net displacement is zero. So the sign convention is a very smart way of doing, because it deals with the initial point and the final point. It does not care about the upward or downward part of it, right? It just worries about the sign and the initial and the final position of the body. This is the beauty of the sign convention, which I will explain you now. Contrary to the beginner level method of doing this, where you first worry about the upward part of the motion, calculation is done separately. Then the downward part of the motion, the calculation is done separately. The sign convention is an advanced way to solve the problems. Using the power of sign convention, you can cut down on the time it takes to solve a lot of kinematics problems, especially the problems of free fall. So we will in this video discuss complete explanation of the beginner level method to an extent, but more focus will be on sign convention using this numerical. So just remember this convention. Anything which is upward is positive because it is above the origin. Anything which is downward is negative. The selection of origin is dependent completely on you, and we can make even the detachment point as the origin. If this is your origin, anything which is going towards this direction is negative. Anything above this is positive, right? The only difference is if you select this as the origin, anything above this is positive. But if this becomes your origin, this line becomes the point of reference for positive and negative. So choice is yours. I generally tend to select either of the two, and I get the same answer when it comes to time or velocity. All right. Having said this, now let me tell you a smarter way. Use sign convention and solve this problem without worrying about this upward downward motion, right? The upward downward motion is a bit of a pain because it would, you have to analyze the motion twice. First you analyze it going upwards, and I will just distinguish between the two and say, okay, so this was your upward motion on account of, because you left the balloon, you went up at this instant, the package also had 12 meter per second, and here it became 0 meter per second, and then it started descending down with free fall and acceleration. It accelerated. Okay, let's say it accelerated. Whether the sign will be plus g? No, because anything downward is negative. Now let's use some smart physics and solve this problem without worrying about it going up or down, right? And this is an advanced way of doing this problem. Many beginner students do this the way I have just explained it. Upward downward motion is analyzed, separate times are calculated, no problem at all. I'm going to tell you a smarter way to solve this problem, and that is a shortcut. And what will be used? Our knowledge of the sign convention. So let's say we are drawing this, and this is your graph. The ground is here. This was your point of detachment. The body continues to move upward, with the package continues to move upward with a velocity of 12 meter. Why I'm writing plus? Because it is upward, right? But the acceleration due to gravity is going to be downward. So this is definitely a case of deceleration. What is this distance? Is it downward or upward as compared to this? If this is your origin, this distance is what? This distance, displacement of the body from A to the ground, for example, A to G. If I were to calculate, the displacement is in this direction, right? So the displacement S is also minus 80 because it is downward. The body goes down. Now we are working smartly. So this is minus 80 meters. So we will not worry about the upper part of the motion, which is, we are no longer worried whether it goes to the highest point, it stops, and we're just going to concentrate on this point and straight away start solving this problem, right, from the point A onwards, without worrying whether it goes up, down, whatever. So let me just put it mathematically. So your initial velocity is upward. So this is plus 12 meter per second. Your displacement is minus 80 because it is downward. We know the sign convention. Acceleration is minus 9.8 meter per second square, or 10, whatever is given in the question. What are we supposed to calculate? How much time does it take for the body to hit the ground? Which means, the package hits the ground here. So so S is equal to UT plus half AT square minus AT is equal to 12 into T plus half into 9.8 with a negative sign, because the acceleration is downward. Anything downward towards the ground, is towards minus y-axis, and therefore negative into t square, right? I hope the equation makes sense to you. The velocity is positive because it is upward. So minus 80 is equal to 12t minus 4.9 t square, and 4.9 t square minus 12t. All right. So I'm taking it on the other side. Minus 12t minus 8t is equal to 0. And t is equal to, obviously this is nothing but quadratic equation now. Minus 12 square minus 4 into 4.9 into minus 80 divided by 2 multiplied by 4.9. And this is quite a pain. I wish I had taken this as 10 and, gotten a better value to solve and play with. So 12 is 12 plus minus, so this is 144 plus 196. So this is 49 multiplied by this is 4 and this is 80. So I'll just multiply by 2 first. 18, 9, 27, right? So 2, 3, 4s are 12, and 14, 8, and 16, and 1, 5, 1, 5, 6, 0. Why? Because, 1, 5, 6, 8, and another 0, 1, 5, 6, 8, 0, divided by 2 multiplied by 4.9. So you can, calculate the value is going to be larger than, so this is minus b plus minus minus b plus minus b square minus 4ac divided by 2a, and we will have to choose one of them, which is, so which is plus, because this number is going to be larger than 12, because under root 144 itself is 12. So you'll get a substantial amount of so this will touch around, I think, 16,000 or something, right? 15,680 plus 144, 12, 8, 15624. So if you do a square root of 156,824, right? This is what you need to calculate as a square root. Maybe around 350, because 35 is close to this. Anyway, you can solve this and get t as the positive one, right? 12 minus larger than positive 12 will fetch you negative. Ignore that. Select the plus one and divide it by 2 into 4.9. That's the time it takes for the body to hit the ground. Now, the smart thing about this whole thing is what? You did not worry about this, right? Whether the body has gone up, and you did not worry about the A and B, right? Going upward, downward. You just, started from here, started writing the velocity as positive, the displacement as negative, the acceleration as negative, and boom, you got the answer, right? It's a very smart way to solve this. If you're a beginner, it's fine to do the A and B motion, but if you want to learn it in advanced manner, this is the way you do this. Now you know the time it takes for the body to descend, and if you know the time it takes for it to descend, then V is equal to U plus AT. This is the velocity with which it hits the ground. You know the initial velocity, plus you need to calculate what? You need to calculate the acceleration, which is, if you're coming down, it is negative, right? So minus 9.8. Time is something you got from here, and therefore it is 12 minus 9.8 into t. Never mind if you get a velocity as negative. That negative velocity, and for all you know, this is a very large number which you calculated from square root. And if you get a velocity which is negative, what it is trying to tell you is that the velocity is downward because of the sign convention. And the acceleration here also is downward. Therefore, both are, in sync, and the body was accelerating when it came down, because the velocity and acceleration are in the same direction, which is what we discussed earlier also. So I hope you've been able to distinguish between the way you solve this problem and understand there is a smarter way to solve this problem, and there is a beginner level way to solve this problem. Both are correct. The smarter way will save you some time, which is a rare commodity when it comes to examination. The first method is good. If you're a beginner, try to solve such problems in both the manner. Solve it with the help of a beginner method and then shift to a smarter way. Compare your answers, you always get the same answer. Watch my playlist on motion in one dimension or kinematics. You will see some fantastic questions being solved from Resnick Halliday and a very famous book in India called as NCERT and many other books. All the best to you, and thank you very much for your time.